Hello everyone. Today our team will present the iterator pattern, which is one of the behavioral design patterns. Our team members are Neshushana, Nishui, and me, Chusulai. So I will explain about the iterator pattern. The iterator pattern allows us to access elements in a collision sequentially without exposing how they are stored internally, and it separates the traversal logic from the structure of the collision, and it is also makes navigation clean, reusable, and consistent. So let's talk about these contexts. Collections can have complex structures such as lists, arrays of trees. Clients often need to traverse them without worrying about the details. For example, in a travel application with flights, hotels, and tour package, users just want to browse easily without knowing how the data is stored. The iterator pattern is powerful because it hides collision complexity and it allows code reuse across different collisions. Moreover, it supports multiple traversal strategies like forward or backward, and it separates traversal logic from the collisions structure. But there are some advantages. It requires extra classes like iterator and concrete iterator. For small arrays or lists, a simple loop may be faster. Iterators usually allow only sequential access, not random access, and it can slight performance overhead compared to the write access. Our team main problem is how can we traverse complex collision without duplicating traversal code or exposing internet details? These are the solution. Now let's look at the solution. The iterator pattern provides an iterator object that implements a standard interface for sequential access. This iterator is responsible for traversing elements one by one without exposing the underlying structure of the collision. So the solution can be explained in three parts. For the first part, the clients always interact with the iterator in the same way, no matter what the type of the collision it is. For the second part, the iterator keeps track of its position and provides methods like hash next and next for accessing items. The last one is the collision itself only creates the iterator, while the traversal is completely handled by the iterator. So next part will be continued by my friends.
This is the example code that demonstrates the basic structure of iterator pattern, and it is the iterator interface. And it have two methods. The first one is hashNet method, which checks whether there are still elements, and it will return true or false. And the second method is the next method, which will give us the next element. So this is an aggregate interface, and that is a class called travel package collections, and it creates an iterator, which means that we could go through the elements step by step. This is the concrete iterator, and it keeps all the travel packages and keep track of position by using index. And it have two methods, hex next and next method. This is the concrete collections, and this is the place where all the travel packages are stored. And we can add packages, and it have the create iterator method so that we could go through all the travel packages one by one. So let's see how we use in practice. At first, we create list of travel packages, and then we add package like flight to Bangkok, hotel in Chiang Mai, city tour in Phuket. And then we ask the collection to give up the iterator. Then the iterator allow us to go through all the travel packages one by one by using hashNet method. And after all of this, it will print available packages by using next method. So this is the process, and it have four process. The first one, forward iterator, it transfer element from beginning to end. The second one is reverse iterator, which is the opposite of forward iterator, and it will transverse element from end to beginning. The third one is filter iterator, and it transfer only element matching certain criteria. The last one is composite iterator, and it transfers nested collections. And iterator has some consequences, and it could be positive and negative consequences. Let's start with the positive consequences. It high collections complexity from the user, which means that we don't need to know how the data is stored, and it supports flexible and reusable transfer strategy and promotes clean separation of transfer logic and collection data. The negative consequences are that it introduces extra classes and abstractions, so that sometimes it could make the design a bit heavier, and it may add slight overhead compared to the simple loop. And iterator have some related patterns, such as composite pattern, which handle single items and group in the same way. Often use iterators to move through tree structures. The second one is a factory method pattern. It helps create the right type of iterator, such as like forward iterator or backward or reverse iterator. The last one is visitor patterns. It separates algorithms from the collection object and adds actions while the iterator go through the collections.
Now I'm going now I'm going to talk about known users. Java collections framework use iterator and list iterator to transfer collections like array list and hash set. .NET framework use immutable and emulator with for each loop. Python use built-in intervention and next function class generator for iteration. C++ STL provide iterator for container like vector, map, and list. Here is case study. Our scenario is inefficient navigation through travel package. If without iterator, that would be multiple operators for flight, hotels, and activity, complex repetitive for loop, scatter, and code, and poor usability. That means users struggle to browse options, and the last thing is hard to extend, which means adding new package type require refactoring. If with iterator, when trouble package iterator encapsulate traversal, uniform navigation across all trouble options, cleaner and more maintainable code struggle, and improved user experience. It is easy switching between flight, hotels, and tours. So here are our class diagram, and we have 5 class. The package iterator connected with iterator class and concrete trouble package collision connected to auxiliary function, and the last one is trouble package class. So, case study. The iterative pattern can address major usability issues, particularly related to navigation and maintainability. So, what is navigation and maintainability? The original design requires separate loop and function for browsing flights, hotels, and tours, which made the system complex and inconsistent. By implementing a trouble package iterator, traversal was unified into a single interface, resulting in similar code, easier scalability, and a smoother user experience when switching between different trouble package types. Thank you so much for your time.